Now we're going to look at some examples of separation of variables. In this video, we're going to look at the Laplace equation in polar coordinates. So it should be a pretty quick video. I'm just going to do one example per video now. I'm going to start doing that instead of a bunch of examples in one video. I feel like this is a better way of doing it from now on. So we're given the PDE. Second dimensional Laplace equation in polar coordinates. If you have taken Calc 3, you will be very familiar with polar coordinates, cylindrical coordinates, spherical coordinates. We dealt with them in different. You can use different coordinates to solve the integrals and whatnot, depending on the object. In this case, we can describe two-dimensional as in polar or cylindrical, and you should be familiar with that from Calc 3. However, don't worry too much about these. These are extreme cases of separation of variables, just to give you some practice. Later on, we're not really going to deal with anything this crazy. These are just extreme examples, just to get used to separation of variables. So, it says, let u of r of theta equal to r of r theta of little theta. Use the method of separation of variables to show r and theta satisfy those two equations. Those are the answers, so it gives us the answers. And it wants us to use k as our separation constant, which is fine. I know I showed using lambda in the last video, but they want us to use k, so I'll use k. Actually, I'm going to stick to lambda for sakes of consistency. Okay. Let's separate the variables. U of r would be r double prime theta. This is that's a capital theta, by the way. Plus 1 over r prime. I'm sorry. U to the r is equal to r prime theta. U of theta is equal to r theta double prime. So now we plug them in. Plus 1 over r prime theta plus 1 over r squared r theta prime is equal to 0. All we have to do now is divide everything by the common term, so they all have an r and theta. So we're going to divide by r and theta. This would help us remove thetas from this one, and be left with just r's. And we'll remove the r from this one and leave us with just thetas. That's the main step in separating the variables. We have r double prime over r plus 1 over r prime plus 1 over r squared. Theta double prime over theta is equal to 0. You can multiply everything by r squared, little r squared. Plus r prime plus theta double prime over theta. Now let's move those over. Negative. I left that space there for a reason, because we're going to include our separation constant, right? Now all we do is write out our two equations, right? So this one would be theta double prime. We add it over, then multiply the lambda by theta. That's one equation. And we're also going to have multiply everything by r, so r double prime, r squared r double prime, plus r. Oh, wait a minute. When I divided by r, I forgot to include this. I was going to say, plus r prime is equal to r lambda. Then we can move that over. I'll write it as lambda r. And that should be what they had up here. Yes, that's exactly what they have. So that's the answer to this one. We have two ODEs, right? I mean, yeah, two ODEs, second order ODEs. And in the next video, we're going to look at cylindrical coordinates. All right.